Hi guys, let's look at the next question. Before I start the next question, let's quickly revise the three new identities that we've learned this year. Sine square theta plus cos square theta is equal to 1. 1 plus tan square theta is equal to sec square theta, and 1 plus cot square theta is cosec square theta. Basically, you need to look at one left hand side or the right hand side and try and reach the right hand side somehow. So if you're starting from the left hand side, you should look at the terms on the right hand side and decide how you want to proceed with the question. So let's look at question number 21. It says sin a plus cosec a whole square plus cos a plus sec a whole square, and on the right hand side I need to reach tan and cot. So I notice that I have on the left hand side no square relationships. So if I square this term the way it is given, only then will I get cosec square. So let's try and first square this. So let's work with the left hand side, and when I work with the left hand side, let's square this. So this becomes sine square a plus cosec square a plus 2 sine a into cosec a plus cos square a plus sec square a plus 2 times cos a into sec a. Let's see what do we get. So I have a sine square a and I have a cos square a. So let's write them together because I know this will give me 1. So this is sine square a plus cos square a. These two terms are gone. Now I have a cosec square a and I have a sec square a. So I don't need either of them. Instead of cosec square, I need cot square, and instead of sec square, I need tan square. So let me just convert this into cosec square a. So I know I'll have to convert this into cosec square into 1 plus cot square a and sec square into 1 plus tan square a. So I have taken this term. Now let me take sec square a. That leaves me with these two terms, 2 sine a cosec a and 2 cos a sec a. So 2 times sine a into cosec is basically 1 upon sine a, which we've done, plus this term becomes 2 times cos a into 1 upon cos a. A reason being, since cosec a is equal to 1 upon sine a and sec a is equal to 1 upon cos a. So let me see if it helps me. This sine and sine gets cancelled, this cos and this cos gets cancelled, and this in any case is 1. So this is 1 plus 2 plus 2. I needed 7, out of which I've got 5. 1 from here, 2 is this, 2 is this. Let's see, this will give me what? So cosec square we know is equal to 1 plus cot square a, and sec square is basically equal to 1 plus tan square a. Now let's write the reasons. So since there are 3 reasons, we've done 3 things, which is sine square a plus cos square a is equal to 1. That's the first one. So in fact, we are using all 3 identities in this question. The next is cosec square a is equal to 1 plus cot square a, and the last one being sec square a is equal to 1 plus tan square a. I think I've already got my answer. This is 5 and this is 1 and 1, so that's 5 plus 1 plus 1 plus tan square a plus cot square a, which is equal to 7 plus tan square a plus cot square a. This is what I wanted. This is equal to right hand side, so hence proved. Done. I hope you realize how we are proceeding on these questions. We look at what is on the left hand side and how can I reach it to right hand side. So, and first thing in this, I realized that we don't have any relationship between sine, cosec, cos and sec. The relationships are only in the square of them. So that's why I squared them, because we opened these brackets now. Let's look at question number 23. Again, question number 23, left hand side looks slightly more complicated. So let's look at the left hand side first. Let me try and take the LCM. The LCM of this will be 1 plus cos A multiplied with 1 minus cos A, right? And this will be multiplied with 1 minus cos A, and the second term will be multiplied with 1 plus cos A. So cos A and cos A gets cancelled. So what I am left with is 2 upon 1 plus cos A into 1 minus cos A, which is basically in the form x plus y into x minus y, which means 2 upon 1 minus cos square A. Now let's look at the relationship between 1 and cos square. The relationship is 1 minus cos square is equal to sine square. So this is 2 upon sine square A. Reason being, since 1 minus cos square A is equal to sine square A. And then this becomes 2 cosec square A. Why? Since 1 upon sine A is equal to cosec A. This is something that we already know. So this is basically equal to my right hand side, and hence proved. Done. So you look at left hand side and see how you can convert the terms on the left hand side to the terms on the right hand side. Wonderful. Let's look at the next question. The next question that we do would be question number 25. So let's look at the question. Question 25 is again, in fact, similar to the one that we just did. So again, I notice that if I take the LCM here, I should be able to get this as x plus y into x minus y, which should help me. So let's take the LCM. Again, I work with the left hand side. So when I take the LCM, I get cosec A minus 1 multiplied with cosec A plus 1. That's my LCM. And the numerator of the first term will be cosec A multiplied with cosec A plus 1. And the second term would be cosec A multiplied with cosec A minus 1. Done. Let's open the bracket in the numerator. So the first term becomes cosec square A. Next term is cosec A into plus 1. That's plus cosec A. This becomes plus cosec square A again. And then the last term becomes minus cosec A. And the denominator is in the form A plus B into A minus B, which means this is A square minus B square. So this is cosec square A minus 1. In the numerator, cosec A and minus cosec A gets cancelled. So what I am left with is 2 cosec square A. Okay. And the denominator is cosec square A minus 1, which means the relationship between cosec A and 1 is cosec square A minus 1 is equal to cot square A. Reason would be since cosec square A minus 1 is equal to cot square A. But I haven't reached my right hand side. So what should I do? I realize I need a sec. Sec is basically 1 upon cos, and here I have 1 upon sine and cos upon sine. So let me just convert this into a basic sine and cos. So what I'll get is the numerator will become 2 upon sine square A, and the denominator will become cos square A upon sine square A. Reason, since cosec A is equal to 1 upon sine A and cot A is equal to cos A upon sine A. I think I've left a little less space. Anyway, let me try and finish this question in this part. Let's see. So what I have now is 2 upon sine square A multiplied with sine square A upon cos square A. Basically division of fractions. So sine square A and sine square A gets cancelled, and I have 2 upon cos square A, which is nothing but 2 sec square A, which is equal to right hand side. Hence proved. Done. Let's look at the next question. The next question is question 27. Again, but let's go back to the previous one. What I did was I realized I can't do anything with them. So I added them first. In any case, I need square relationships. So when I squared it, I realized I reached I could solve it to a point where I was still not reaching the right hand side. I looked at the right hand side and realized I need only cos here because sec and cos are correlated. So that's how I converted cosec into sine and cot into cos and sine, and once I worked on it I got some answer. Perfect. Let's look at question number 27. Question 27 is 1 plus cos A upon 1 minus cos A is equal to tan square A upon sec A minus 1 whole square. So this time I realized that the right hand side is slightly more complicated than the left hand side. So let's start and work with right hand side. Can I get the answer from the left hand side? Yes, I will be able to, but in this case the right hand side looks slightly more complicated, which means I should be able to get the answer faster. So I will convert, since I notice that this is tan and sec, whereas the left hand side is only sine, cos, or not even sine, only cos. So let me just convert this into sine and cos. So tan square is basically sine square A upon cos square A, and sec A minus 1 can be written as 1 upon cos A minus 1 whole square. Okay. So let me just write the reason as well. So the reason would be, since tan A is equal to sine A upon cos A, and the second reason is sec A is equal to 1 upon cos A. So these are the two reasons why we've done this step. Next, let's take LCM and see what we can do about it. So this becomes sine square A upon cos square A multiplied with, so I'm taking off the denominator, I'm converting this to multiplication of two fractions. So this would be cos A upon 1 minus cos A. If I add the denominator, this would look like 1 minus cos A upon cos A. When I take it in the multiplication form, this is what it becomes, and this is square, cos A upon 1 minus cos A whole square. So then I notice that I can cut something. Let's see what I can get. So this numerator now is sine square A, this is cos square A, this is cos square A, and this is 1 minus cos A whole square. Cos square A and cos square A gets cancelled, and what I am left with is sine square A upon 1 minus cos A whole square. Let me look at left hand side and see what I need. So on the left hand side I have 1 minus cos A, which means I have reached here if I can remove the power 2. And in the numerator I don't need sine, I need cos. So is there a relationship between sine and cos that I have? Yes, the relationship between sine and cos is that instead of sine square I can write 1 minus cos square. So let me just replace sine square A with 1 minus cos square A. So the numerator becomes 1 minus cos square A and the denominator is 1 minus cos A whole square. The reason would be since sine square A is equal to 1 minus cos square A. Now this is in the form x square minus y square, which means this can be written as x plus y into x minus y. Repeat, this is in the form x square, in this case 1 square, minus cos A whole square. Perfect. So this I can write as 1 plus cos A multiplied with 1 minus cos A upon 1 minus cos A whole square. This part and the second term here gets cancelled, and I am left with 1 plus cos A upon 1 minus cos A. This is my right, not right hand side, we started with right hand side. This is my left hand side. So hence proved. I can write a reason here, since x square minus y square is equal to x plus y into x minus y. Perfect. So that finishes this question for us. Let's look at some homework questions. So homework questions for us this time would be question number 19, question number 22, question 24, and question 26. Perfect. Thank you so much. Take care. Be safe. I'll see you with the next video.